Hi, my name is Dilshair and I'm here to give you the presentation of STT500. This is the topic of this presentation is to focus on understanding health insurance charges. It is the critical area of study given the significant impact of healthcare cost on individual and society. So here's the introduction. The data the datasets used in the analysis come from Kaggle, a reliable source from data science project with 113.38 observation. The dataset is robust enough to draw meaningful conclusion. The dependent variable is charges and several independent variables are analyzed including age, sex, BMI, children, smoker status and religion. The primary objective is to identify the key factor influencing health insurance charges. This is crucial for both insurer and policyholder as it can inform strategies to manage the cost and improve healthcare affordability. So the graphical analysis reveals several patterns. Charges tend to rise with BMI, including that higher BMI generally leads to higher medical costs. The age histogram shows a population in the 18 to 22.5 age range, while the BMI histogram indicate that most people are the normal of weight. There's a clustering of data point between 20 and 40 BMI and 0 to 40,000 charges, suggesting a significant portion of a population with moderate to high medical expenses. Outliner with high changes regardless of BMI highlights the presence of the extreme medical cost in some cases. Look at our initial graphical analysis. We can see some interesting patterns. Males tend to have higher charges than female with a difference of over $1 million. Regionally, the Southeast has the highest charges. Interestingly, smoking status affect male and female differently with male smoker incurring significantly higher charges. The analysis of categorical variables shows that male charges are higher than female charges. This gender difference is an important finding that can influence actual collection and insurance policies. Despite what our graph suggested, we are conducted a t-test to compare smoker and non-smoker. We found no statistical significant difference in mean changes. This highlights the importance of statistical testing between visual analysis. Our first model used BMI to predict charges. While BMI is a statistically significant predictor, it's only explains about 3.93% of variance in charges. This suggests that while BMI is important, it's not telling the whole story. So look at our model assumptions. We see a curved relationship between BMI and charges, potentially violating the linearity assumptions. However, the assumption seems to be met as we see relatively constant variance in our residuals. It's important to be aware of common violation in linear regression. In our case, we are seeing potential nonlinearity, which we might address through nonlinear transformation. We also observe some extreme value in charges, which could be addressed using robust regression techniques. So moving to our multiple regression model, we included age and number of children along with BMI. This improved our R squared to 12.01%, with all predictors being statistically significant. However, we are still leaving a lot of variance unexplained. In our multiple regression, we see again potential non-linearity, especially with BMI and number of children. The assumptions still appear to be met. We didn't assess multiscalarity, which could be a concern and worth investigating in future analysis. Comparing our models, we see that the multiple regression provide a better fit, explaining about 3 times more variance than the simple regression. However, even our best model only explains 12.01% of variance in change charges. BMI appears to predict insurance charges in the simple model. Age and BMI are highly significant with low p-value, while the number of children are less so. The multiple regression model show that all 3 variables predict insurance charges. So our key finding shows that age are the strongest impact on charges, followed by BMI. The number of children has also a significant, though modest impact. Importantly, we have observed potential non-linear relationship, particularly with BMI. So the conclusion is age is the most impactful predictor of charges. While we have identified several factors influencing insurance charges, our linear models have limitation in capturing the complexity of these relationships. The low explained variance suggests that there are other important factors we haven't captured. Thank you so much for your time.